This is a video to introduce the daylighting simulation workflow in Climate Studio. So let's say that we want to study how much visible light is entering this little building, our cube, that we've been working with this semester. And I've got a simple facade with a single piece of glazing on it on the south side. I'm going to go to I'm in my CS Workflows, Climate Studio Workflows tab. I'm going to go to the Daylight Availability. There's a bunch of drop downs here that we can choose from. Just leave it on lead 4.1 option 1. We're not going to talk about what that is right now. You'll get into it later. But the point is that in order to simulate sun interacting with a space in Climate Studio, we have to first decide what objects or surfaces or things in our model we want to be interacting with the sun. And that means they're either going to be blocking it or reflecting it, or probably a combination of both. So in this case, we've got a ground surface. We've been taking our models outside and putting them on the asphalt in front of Ed Hall or in Manhattan, I guess, taking them. I'm not sure where you're putting them in Manhattan, but you're putting them somewhere. And so there's either going to, we've done it, we've included shading in some instances. So if I went outside and I placed my cube near a wall, I would include that wall. Right now I'm just going to have a ground surface and the cube itself. But so the sun is going to hit the ground and be absorbed by and bounce off of it in some way that we can define material specifications to control. Then it's also going to hit the building itself and be reflected. It's going to go inside this window and then bounce around inside. So in order to, the first thing we have to do is then tell the simulation what things in the model we want it to see as being interacting with the sun. So in this case, we have the ground plane on this layer, and then I have in this massing set of layers, I have southeast, northwest, roof, and floor. I'm actually going to turn off this south because I've got a separate south. Let me turn on the shading here. I'm using the south from a set of layers that I'm using just for daylighting. There's no rules as to how you should exactly organize this, but the point is you want to get in the habit of organizing your models to where you can easily turn things on and off, and also so that you can keep track of iterations that you've run. So that's up to you to figure out how, but I'm going to be, as I look at your models, I'm going to be coaxing you to improve on this approach. All right, anyway, so I've got some stuff that I want to tell the model to interact with the sun, or that the sun needs to interact with. And so I'm going to go to my Climate Studios Materials tab. It's also, I always keep this in my, wherever the panel I have with my layers, I like to have that easy access to that. But it's also always, if you're going to be using it in your simulation, it's going to be in here also. Oh, by the way, I'm using a Long Island, ISLIP Long Island climate file. We need to have a climate file that makes sense for our location. Anyone in New York will work for the sun, and that means the New York City area. Okay, so if I go to my Materials tab, from my Climate Studios Materials tab, I see that I decided just to make everything concrete. I'm going to click on the ground and just show you. So I picked a concrete exterior wall. You can obviously search here in your library. Why did I pick that? I just wanted to keep it simple. There's a bunch of these concretes, so I picked this one. But the point is here that this has a visible light reflectance of 33%. Now, we're not just dealing with visible light right now. We're actually dealing with heat and visible light. So we're talking about the entire amount of energy that's bouncing around. But in Climate Studio, that's for these materials, this is the variable that we have control over. And so we're going to assume that it's the same, it has the same reflectance for all portions of the spectrum. All right, so the point is that I've got this material, concrete exterior wall, chosen for all of my layers. I mean, so for both my ground and for my wall surfaces. or my cube surfaces. Now I definitely could have chosen asphalt here, and maybe there's because that's what I'm going to be sitting it on in old Westbury. Um, to really, and there's a bunch of different asphalts, and they have a pretty wide range of reflectance values. If we go back to concrete, there's a really wide range of reflectance values for concrete also. So it's not really the material we're talking about here. Um, there's a concrete that has a 70%. It's like a yeah, this one here, exterior concrete wall, 71%. So these are based on actual. One's called 100 Memorial Drive. I think that's a Frank Lloyd Wright project. So it's not so much the names of the materials that we're interested in. It's these specifications that we've talked about in previous weeks, which is one reason we're doing that, right? We want to understand these specifications so we're not just slaves to some name that really has no meaning, because the material specifications can be very different for all these generic terms like concrete. So if we're really going to do this right, we're going to test or look up or find some way of determining what the reflectance values are for our chipboard, and we can talk about that in class. But for right now, I'm just keeping it as this simple single material for the ground and for all the surfaces. So that will now, if I run a simulation, it will bounce the sun off of those materials using those surfaces using those material specifications. The next thing I need to control though, I guess I'll go to ghosted, is, well, there's two other things I need to set up. Now one is I also have a piece of glazing here, a glass material. It's important to also, these little details that you need to get used to, or you'll be frustrated in any program you're using. You have to learn the details, obviously. But if you're applying a material to something that you're just saying, okay, simulation, I want you to block the sun and reflect the sun off of this. It can be a volume, it can be curved, it can be pretty much anything as long as you can apply material to that layer. For pieces of glass or for glazing assemblies, because this could be a triple pane piece of glass, it could be double pane, it could be a col wall, block unit, whatever. In Climate Studio, we're just saying this is going to be a translucent material, and so if I go back to my Climate Studio materials, I've got this. This is the glaze. Let's make sure, and always check. So I'm going to go turn this on and off if that is on the right layer. I would say 80% of the time that people come to me with problems with Climate Studio, and they're saying there's something wrong. I don't, I've deleted it and reinstalled it, and go to these extreme layer measures to try to fix problems. It's almost always something like that, where they just don't realize that what they think is on a certain layer that has a material applied to it is not on that layer. So again, as architects, it's just we're generalists. We got to learn all these things, and you'll forget it because you don't use it for a while. You just got to get good at troubleshooting. And to troubleshoot things, you change one variable at a time, and you just have to engage that critical thinking that we all have access to try to solve problems before you panic and think it's it's generally not your computer or the program. It's a user error. Okay, anyway, so I'm in on this layer. I'm going to go set the material here. I'm picking just a single pane piece of glass. Actually, this one might be double pane, but it doesn't matter in the same reason that we talked about earlier. All we're interested in is the visible transmittance because we're talking about daylight. And we've talked about this before. But so hopefully you definitely should know what solar heat gain coefficient is because we've done exercises in Climate Studio with it and covered it in some detail in several lectures. And we can have a solar heat gain coefficient that's high or low compared to a visible transmittance. That's the whole point, or that's a really cool thing we can do with glazing now, is that we have these custom glazing packages we can order, and we can custom design the performance. For this situation, you're probably... and look at let me just pull this in. This is the assignment. Another thing I want to say, and give your professor and me, do us a favor and do this right, which is you need to read these instructions and then ask questions. If you say, oh, what are we supposed to be doing today? I'm not being rude if I say, don't ask me that, read the assignment, because I'm not going to tell you accurately what's in here. There's a lot of detail. and I might misquote it, or I might forget, or you might misunderstand me. This is a little scope of work, just like if you were at a professional firm. And you need to read it and ask questions about it because there may be mistakes in it too, right? So that's a point I've made a number of times, but please do that. Um, but if you read through this, for example, I have suggestions for what you would use for glazing. If you're gonna, if we're gonna, what we're heading toward, by the way, with these exercises is the last week of class. We're gonna go outside. Hopefully, it's gonna be a sunny day, and we're going to take everything we've known, all of the facades we've generated, and experiment to try to control all the variables we've talked about, or as many of them as we can. Um, so if you're going to control temperature inside your cube, you're going to have something over your openings, over your so you're going to have glazing. I mean, you could try it with just holes, but that's going to be difficult if it's 40 degrees outside or 25 degrees outside and we're trying to raise the temperature inside the building. We will be able to do that with the sun, but not if we just have air going through. So I would suggest you get together with friends and pool to get something like this. This is just something on Amazon. You could find anything you want, but the point is here, it's a 20 pack of 12 by 12 plexiglass for $26. That's a little bit over $1 per sheet. Plexiglass is very easy to cut. This is only a 16-inch thick in this example. You can score it with a knife and break it. So you could make small pieces. You could tape them to the back of your facades, or you could put a full piece behind your facades, whatever you want to do. But that's the point is that what we're doing today, though, is or what you're doing in the assignment this week, is you are trying to create a daylighting design that meets a certain target goal that we've got, and then you will fabricate it later. So we need to then be using materials specifications that we think are accurate to what we're actually going to be using outside. So in this case, then, I'm going to pick something that has a pretty high visible transmittance. I have a tool in Old Westbury, and actually I probably should have found something that had like an 85, because I think that the plexiglass I've got in Old Westbury has a visible transmittance of about 85. I haven't really. I want to be more systematic about how I test it. But the point is that if I'm going to be taking my cube outside with plexiglass in place, I need to simulate with something as close as the specs for that material as I can. So it's going to be high. It's going to be 91 or 85 or something like that probably. We don't have an infinite choice here, and we can't. It's not easy to make your own glazing materials, so just pick one of these. Anyway, in class we can talk about what's the best choice, and I will. In Old Westbury we can measure the plexiglass I have and get a good number. We can also get the solar heat gain coefficient for that value with the tool I have. But there's not a problem with just estimating it either, or looking it up, in a chart. Another thing I want to say right now. Well, actually, let me finish that. So the point is, we're looking at the visible transmittance, not the single or triple pane. Like as you choose different materials here, the graphic changes. So if here's a triple pane. Oops, moved it. Go down and find it. Yeah. So if I pick a triple pane piece of glass, it's going to the graphic is going to turn to that. I've got a lot of specifications here. So this is a very low visible transmittance, 30%. You can see it looks pretty dark in the graphic. A low solar heat gain coefficient. If I add a shade, that shade will show up. You do not want to add shades for these exercises. That's something we'll talk about later, what the shades are for, but just do not include them. So we always want that to be no shade, the second tab. And then, like I said, you can reorganize these materials by clicking on the column. So I'm just going to, for these simulations, I've run it with a assembly, or actually a single piece of glass that has a 91% visible transmittance. So I select that. I actually already have it, and that is what is on this this piece of glass. But so the point that I was making, or one of the points, was this is a single planar surface. If I were to want to have a triple pane piece of glass here, it's still going to be a single surface, because as we saw here, we are able to define the specifications of that surface by choosing these specs here. And so if we were to have, if I were to add two more surfaces out here to emulate the thickness of that actual assembly, I would really be messing up my simulation, because I'd be actually having 9 panes of glass and they'd be separated. It wouldn't be a realistic estimate. All right, so now I have everything I need to either block or transmit the sun. All of those things are blocking and transmitting. And, well, the opaque surfaces are blocking and reflecting, and the glazed surface is transmitting and reflecting. Maybe I should just go over this again. We have two drop downs here, or there's actually a number of them. For anything that's opaque, an envelope that's solid, choose an opaque material. For glazing, please just use the exterior glass dynamic shade optional. We don't want to be messing around with electrochromic glass or anything of that right now. That's something for later. So you're choosing that tab, and again, we're always saying no shade. Okay. So now I have the model set up and I have the layers on that will interact with the sun in the way I want to. The next thing I want to do, though, is decide where do I want to measure the sun, right? And that's what, whenever we have the little black dots, those are fake sensors. So in this case, I want to measure it on the floor, or actually above the floor. I have a layer here called floor sensor. I'm actually going to go ahead and turn off let me go to my workflow. I'm going to turn this off so you don't see that. So what I did here is I just made a surface a little bit set in from the exterior of my envelope. You don't want it embedded in your envelope, especially if you have thickness, because there's going to be a portion of your censored surface that's inside of something, and so that's going to mess up your estimate, your simulation. So I set it in a little bit from the edge, and now I need to tell Climate Studio that I want this to be a work surface. It's called something where I'm going to be measuring the amount of, in this case, the amount of visible light that is hitting a surface. So I'm going to add, and I've already done it. So if I select the surface, it has to be a planar surface, and I click Add. This dialog opens up. Let me not do that. And go ahead and set. Remember, this is an 8-foot, or you either have an 8x8x4 or an 8x8x8 volume that you're dealing with. I would set the sensor spacing at 1 foot. The question then so that's the sensor spacing. Then the sensor inset is how far it is from the edge. I think you can put this at 1. I have it at 1.5 for some reason, so I'll just leave it at that. But you can let's just change it. So we'll see what that does. The work plane offset is how far we are off of the. So we've selected a surface on the floor, and then we say, okay, where do I want to place this work surface? And that depends on what you're doing in the space. If we are, I don't know why I decided it's that I had said okay, but anyway, it's showing the work surface inside now. The typical height for this, if we were talking about an actual room, would be 30 inches, about desk height. But if you're looking at a gym, you'd put it on the floor. If you're looking at something, a lab that has higher surfaces where the light's going to be hitting, that the people are going to be working at, then you place it based on that height. But I just decided to put it at 1.5 feet. If I put it in this small little building at 2.5, at 30 inches, it seemed too high. You can put it wherever you want to. There's no right or wrong to that. We're just deciding where we want to have our sensors. Now, something that people often do here, so I'm just going to say, okay, there it is. This is a single surface because all it is, we're defining a virtual, basically a little test kit. We could say that we've got a piece of plywood that we have outside, and we set our sensors on, and we bring it in, and we set it up inside the room. This is what this is emulating. But if we were to make this a volume, like if I were to come out here and say, if I wanted to make this a work surface, I'll go ahead and do it and say okay. Now I've got, I've got all these, I've got a work surface on the top, on the bottom, and the sides. If you don't do an offset, then you may not even notice this, and so people will sometimes do this where they're running a simulation where they've got a bunch of surfaces in places that they don't want them to be, and they get results that confuse them. For example, because we're going to get zero sun hitting this bottom here. So if I ran this, then I would have. Well, actually, let me do one thing. I'm going to edit this. Oops, I want to edit it, not remove it. If I set my work saying offset, I don't have to let me do zero. Let me try it. To zero, yeah, okay. So now I've got this box, and I may not, if I had made it a little bit, if it was really large and just had a very small, um, you know, thickness to it, I might not see this. And so now I'm going to be measuring all around this volume, and so I'll get a lot of places like on the bottom where there'll be no lux value at all. I won't notice that because it's going to be underneath and I won't see it, and I'll then get a really an average that's way off what I think I should get. So just be conscious that you are only, it's a single surface that we want here. Let me just go and delete that. Okay, so now I have everything that's blocking, reflecting, transmitting the sun, and I've set the place that I want to study the amount of sun, visible light that is hitting that surface, and that's going to be illumination in lux. All right, so now we're ready to start running some simulations. The first thing I'm going to do is just run, just see what I would call this my baseline. I've got my cube with my facade on it. I've got my work surface set up, so I'm going to run a simulation. And this is the output I get. So let's just analyze this for a moment, and then I'll go. We'll look at a number of simulations that I ran. So first of all, ignore the 3 credits, the 100%, the SDA and ASE. That's a really cool thing we'll talk about later. What we want is our lux here. So we see that we have an average lux of 7,300. We can mouse over our individual sensors, and understand in more detail how this is working. This does make sense. We've got more toward the front and the back because if we go back and look at the sun, this is always a good thing to do. And let's if we go to, I'll turn on the sun path. In the winter, the sun's going to be low and coming farther in, but in the summer it's going to be a lot of it's going to be blocked by the building itself. And so, but any sun that comes in the summer will be more toward the front. As we go toward the east and west, we'll get further into a corner at different times of year. But so then if we go back to the simulation results, then we can, then this sort of makes sense, or not sort of, it does make sense in terms of our understanding of the sun. And if we switch to specific days, we can, let's look at, noon throughout the year. Should be that in the summer we have less, and in the winter we have more, which is true. And if we go before noon, we'll have more on this side, on the west side of the building, because the sun's going to be on the east side shining in, and in the afternoon we'll have that more on the other side. So this is all making sense, right? And we understand that we have access to both the full year average and individual hourly, daily values. Okay, so let me go back and turn this guy off. So what is this telling me? Great. It looks pretty for one thing, and I've got some results. But how do I analyze it? First, I want to point out that I've got this. You always need to include, when you're talking about your results, the range that you've chosen. Oh, and by the way, this is something that happens a lot. I just want to remind, just cover this once. It's often going to be. You see, I've run a ton of simulations in here. So I have my results that I've named above, and then I've got my name simulations above, and then I have my results below. Sometimes these get closed together where you can't see. Like, for example, I can't see the chart right now. You have to find these little, and especially on laptops, for some reason, it's almost like they're stuck. It's really hard to find them. Then once you find them, they seem to maybe it's just because we know where they are, but they just work better. So you will always have, and you can just go on the website and see what the outputs look like, or look in these videos. You always will have access to this data In a daylight simulation, if you're not seeing it, that means you just need to find this little uh, dialog bars that you can pull. All right, so is this a lot of daylight? Is it a little bit? Maybe should know this already from things we've talked about, but the way we're going to look at it right now is based on a chart that I've got in the assignment. So what we've covered so far is setting up the baseline. Now we need to have a goal that we're shooting for. So there's a chart, and this is just one. You can find a lot of these, and they'll have different values for different countries. It doesn't really matter. Just pointing out that we have something called target lux, which is a range of illumination values in phocandles or in lux that would be appropriate for a given type of activity. And like I said, that's defined by jurisdiction, it's defined by country, it's defined by maybe your the company you work for. But just go through and look at these to get some idea. 3 to 500 is maybe a smart one. There's a lot of them that are 3 to 500, but you can pick whatever you want to. But you need to have a target, and then you need to identify that, and that's what you're shooting for when you're doing your simulation. Okay, so then I think I said my target was 3 to 500 lux. So, whoa, we're way, way, way above that, right? We're at 6,500 here. The lowest possible we've got way back in the corner is 2,600. Our average is 7,300. We're trying to get to 500. So the point here is that, and this is, first of all, very small building. It's going to be extreme in this case. But you're going to find and this is one reason why it's really good to be learning these simulations at this point in your careers, and hopefully making them part of your just normal sort of sketch level studying of what you're doing, because glazing can just have a ridiculous amount of light coming in. That's also going to be heat often. It's going to create glare, discomfort. It's going to cause problems, and so we need to get this figured out early in the process, so that we don't have to be doing some crazy value engineering or reverse engineering at the end of the process. So we know this is way too high, and I'm going to go now. I'm just going to go to the ones I've run. So the first thing I've got this. I set my visible transmittance at 0.9. Well, the first thing I did is I thought, okay, well, I can go change that visible transmittance to something lower. All I have to do is come in here, pick a different glazing. I did that. I changed it to something that had a 0.45, and we see it basically cut it about in half. That makes sense, but we're still just crazy high. I did really just to show you why you don't want to do this. I turned on blinds, which knock this way down. We're still actually above where we want to be, but 48% open. That's for 24 hours a day. So we're really almost always closed right now, because if we say that we're the blind, we have 50% night or darkness and 50% light, then these blinds are pretty much open all the time that the light's out. Now that's that's too simple. They're definitely, if we click through and look at when the blinds are open and closed. Like if we go to winter, that's when they're definitely going to be closed most of the time. When you see this white in front, that means it's closed. So if I'm just scrolling through winter, it's closed most of the time during the day, right? So we don't want to use blinds. So the next thing I tried was and by the way, layer states are a good thing to use here. I didn't really do it very much here, but I do have several layer states. I've got just the cube by itself. I've got I would have to. Let me show you another thing too. I can turn off my simulation run here, and to really see what I was talking about, if I go to shaded, unless I didn't set these right. Yeah, actually, ignore that. The point of these, I don't know what these are set on, and anyway, the point of layer states is that I'll just set one up right now. If I go, let's say I want to have the site off, and I want to have well, I know what it was. It was because I had other layers on. Anyway, it doesn't matter. Um, let's say I want to see my cube with the south side off. I can now say, okay, I want to use that another time, so I'm going to create a layer state. I'm doing these in order, so I'll call this south off. So if I go to a different layer state and then come back to south off, it will be what it was. That's the layers that I want on for a specific purpose. So that's a good thing to a good way to be able to switch back and forth between different settings you've had for simulations. Because remember, and you have to learn this for different things in different simulations in Climate Studio, the graphics window is not the simulation. So what I'm seeing right here, right now, is not going to be what is displayed or what was open in the actual simulation or what was on and reflecting the sun or blocking it or whatever. The way I know what was on is I come to this information. This is for daylighting. This is different for different simulations. And it tells me which layer. Let me close that because I don't want to pop it open. It tells me what layers were on and what their material settings were. So that's very helpful. All right, anyway, so my point is that if I was going through this and now showing this in a graphic, I would want to have a layer setting like this so that my I have a 2-foot header shade that I put over, which did drop also. So the difference between this run and this run is only that I have a 2-foot shade. And that's a pretty big change, but I'm still just way too high. So what could I try? I could try to make the visual transmittance of the interior material, or the visual reflection of the interior much lower, so I would get less lux bouncing off the walls. But still, most of this is coming through this window and hitting it directly, so that's not going to help very much. I could really reduce the visible transmittance of the glazing itself. I could pick some other overhangs, and I could try light shelves. So in this case, that's probably not going to do anything. I could try different facades. I could turn my whole model around to the north or the east or the west. I could try tons of different things, and I need to look at the book and listen to remember what was said in the lecture to find all the huge number of variables. But I'm just going to move quickly because all I was really trying to do here is to show you how to set this up, which I've already done. But now just a couple examples. So what I did is I switched to a okay, I got to figure out why that's on. Okay, that's fine. So this was my first run, and now I'm going to try a glazing, reducing my glazing amount. I'm still on the south side. Still, my first run for S2, I'm saying that South 2, is a visible transmittance of 0.9, and wow, I get a huge difference. That reminds me of another thing, though. Now I've basically got just this blue field. That's not really very useful. What I typically try to do when I'm setting these up, or when I'm after I've run all the simulations that I want to run to solve one problem, and then maybe I want to create some graphics to compare them, I can come back and change my colors, my range to. It's best to find a range that works for all of the simulations you're going to show, because then you can really compare them visually. Here, the difference is so stark that I really can't do that. Because if I'm at 5,000, this is kind of useless as far as I can still have my outputs, my values, and my sensors, but I don't get any really visual information. So I'm going to go set this at 500, and now I've got a much clearer set of information about what's going on. I'll switch back to my annual average. But like if you look at my little example in the assignment, and by the way, what I'm showing right now is very basic and not that interesting. I'm not saying it's not fine if you were doing something like this. Just definitely don't just copy this. But you'll see that I started off with 5,000 for my range up here, and then I changed it to 500 for these for the second glazing uh, iteration. You can also change, you should pick a color um, palette that you like and stick with it. You don't need to do it right now, but I'm saying eventually you kind of want it to be that you have a color palette that is consistent through all of your studies. So actually, let me go to if I come to the cube. This is a solar study. I set this at, let's say, 500. Yeah, so these are, you know, none of them are right or wrong. I just personally I like this third one because it's, to my eye, this is cool, and this is hot, and this is not quite as hot. But it's irrelevant. You can do whatever you want to, but I would keep them the same. Is what I'm saying. Is we want to get to where the colors are meaningful. Always include the numbers because the colors are not meaningful if we don't have numbers associated with them, but they're very helpful for graphic presentation. So I'm going to now go back to my simulation and make the point again that so when I first ran it, I had this set at 5,000, and that made sense for the initial runs for where when I had the large glass, when I had this glazing set up. Um, when I had, yeah, so up to here. And then what I'm saying is that when I got into this, since it was so drastically different when I switched to the second glazing setup, I changed to 500. Now I could set this to be, 300 to 500 if I wanted it to be just within the range. I could come in here and say if I'm above the range I've set, pick a color. I'm going to make it, I don't know, I'll make it, I guess, oh wait, I'm sorry, I got to click here. I'm going to make it something different. I'll make it, because if I made it red, I don't think it would really read. Well, I'll try it. I'm going to make it red for the top. Or actually, no, let's try this. I'm going to make it white if I go above, and I'm going to make it black if I go below. So now what we're saying is anytime I'm above or below my range, I am going to black it out. Let's see what happens as we move through. I mean, that's not as interesting a graphic, but it's much clearer that we're outside of our of the desired range that we want. So there's a lot of options, is what I'm saying. Okay, but then the final thing that I guess I want to, so I started with in S2 with this. I have the same glazing as I had for the other one. I've got the same for the first iteration of glass. I've got the same materials. I'm going to set this to 0 for this range here. So you can, I mean, it's just a wide variety of. You've got to really be conscious of the color range you set, and mainly be thinking about the numbers. So then I went from this, which was now I'm actually in my range, maybe even a little bit low, but just for the just for the sake of iteration, I can now add my header shade. So this would be like the last iteration with this glazing layout, right? So maybe, and if I'm, for example, if I have a solar thermal design that I've been doing where when we're trying to get a certain temperature inside, and we're trying to, we did that last week where we're trying to design a shading strategy that brings in the winter sun that we want but blocks the summer sun that we don't. Maybe I'm going to try to develop a daylighting design that matches that, so there would be, a reason to have this overhang here, whether or not we needed it in our current iteration. But I want to make one. I should change this. Remember that. So all I've done so far is I've changed the size of the window, and I've changed the visible transmittance of the glazing, and I've changed the size of the glazing, and I've added shading. Remember that, especially for your little cubes, changing the interior surface will have a huge effect. So if I go into, and I'm doing this in one, actually no, I do have two here. So if I go in and I do a light shelf inside, So let's just look at the difference. So here, without the light shelf, it's actually kind of nice because it's pretty even throughout, which is our goal. We're trying to get an even throughout. I would want this to be more. So what I might try is come in just with this exact run change the color inside to bounce more light off the walls. That'll also be a more even. That'll make it be pretty even. It should be, I think. And then we can bring up these numbers, but keep the distribution sort of the same, hopefully. Another thing I can do is add a light shelf. What that does, obviously, is, and let me turn it on to give, if I put a light shelf here inside, I now have sun coming in and bouncing off of that light shelf. So I'm pushing more light to the back. So maybe I don't want to have something right up here at the front. That would be a reason to use a light shelf. But then the final thing I did just to play around for this demo was to uh, paint the interior of my building white. And you see I get a massive change from that. So I went from an average of 301 to an average of 401. And if I go to the annual, it's a drastic change. So like especially, let's see. One thing, a light shelf is going to even out the differences over the different seasons. So anyway, just look at both is the point of annual and the specific day. Part of this is to get to try to meet your goal. The other is also to learn about daylighting through using the simulation as a tool where you can quickly make changes and see their effect and see if it makes sense to you and try a bunch of different things and see see if you can make it the worst as you can make it. See if you can make a line that goes down the middle, on at a certain day of the year. There's a lot of things you can try. All right, so I think that is all I need to go over. Just remember to read the instruction closely and ask questions. And we will see you in class.